Yes, it's Uncle Jegs. So this is the third Corona lockdown lesson, Mass 2 equation. For this lesson, we're gonna see how to construct a balanced equation from the masses of our reactants and products. But before all of that, chop the retrieval questions and then I'll show the answers, yeah? Ionic bonds form between metals and non-metals. Covalent bonds, on the other hand, form between two non-metals, two or more non-metals. And finally, metallic bonds form between metal ions or metal cations and delocalized electrons. Just a quick recap from the main idea from the last lesson. We looked at reacting masses. In this example, we tried to find out the mass of carbon dioxide formed from 24 grams of carbon when it reacted with oxygen. If you haven't seen that video, what are you doing here? Pause this one, go on to that one, and then come back so you are not confused. You can think of this lesson as just the complete reverse of last lesson. Now, don't get rattled by this question. It's not as bad as it looks, yeah? Sodium hydrogen carbonate, and it gives you the formula here, undergoes thermal decomposition to produce sodium carbonate, water, and carbon dioxide. So this first sentence just tells us what our reactants and what our products are. When 33.6 grams of sodium hydrogen carbonate was heated to a constant mass, 21.2 grams of sodium carbonate was produced along with 3.6 grams of water. Determine the balanced equation for the reaction. Let's put all of this into simple English. We just heated 33.6 grams of a compound called sodium hydrogen carbonate until the mass of it stopped decreasing. Now we're left with 21.2 grams of sodium carbonate and 3.6 grams of water. Notice that the question didn't tell us anything about the mass of carbon dioxide formed. And now the question is directing us to determine the balanced equation from this reaction. So the first thing we have to do is work out what the mass of carbon dioxide formed was. And from the last video, we looked at the law of conservation of mass. Our reactant is sodium hydrogen carbonate, and that is broken down by heat to form sodium carbonate, water, and carbon dioxide. We can put this into an initial equation to help us out, showing that our reactant is on the left hand side of the arrow and our products are on the right hand side of the arrow. You should then write the mass that you get from your question underneath your equation. The mass of carbon dioxide then must be the mass of our reactants minus the mass of the other products. This gives us 8.8 grams of carbon dioxide. I'm just gonna leave this equation up here. Try and clock what we need to do now, yeah? Look at what we have in our question. Look at what we have to work out using our periodic table. And then logically, what should be our next step? Pause the video and honestly try and absorb all of this, yeah? We can work out the moles of each of our substances. We have the mass. Using our periodic table, we have our formula masses, so our molar masses for each of our substances to work out our moles. Let's first work out the moles of our sodium hydrogen carbonate. Moles equals mass over molar mass. You are usually given the RAMs, your relative atomic masses, in the questions. This should save you time checking it up on your periodic table. We have one atom of sodium, 23, one of hydrogen, 1, and 1 of carbon, 12. And we have 3 of oxygen, so 3 times 16 gives us 48. All of this summed up gives us 84 grams per mole. Now we have the mass and the molar mass, so 33.6 grams over 84 gives us 0.4 moles of our sodium hydrogen carbonate. Now have a go at working out the sodium carbonate. Pause, attempt, and play. The relative formula mass or the molar mass is 2 times 23 for our sodium, 1 times 12 for our carbon, and 3 times 16 for our oxygen, which is summed up to give us 106 grams per mole. Mass over molar mass is mole, so 21.2 grams over 106 grams per mole gives us 0.2 moles. Now do the same for water. Our molar mass is 18 grams per mole, which means that it's 3.6 grams over 18 grams per mole, which gives us 0.2 moles. And therefore the final mole to work out is carbon dioxide. Once again, mole is mass over molar mass, so that's 8.8 grams over 44 grams per mole, which gives us 0.2 moles. Now let's go back to that unbalanced equation. We should now write the moles underneath each of our substances. The next important step is to divide the moles by the smallest number. This is done to find the smallest whole number ratio. In this example, the smallest is 0.2. So the ratio for sodium hydrocarbonate is 2. And for the others, since the others have a mole of 0.2, is 1. Therefore, this is our balanced equation. 2 lots of our sodium hydrogen carbonate decomposes to form 1 mole of sodium carbonate, 1 mole of water, and 1 mole of carbon dioxide. Now have a go at this question. Sodium nitrate decomposes on heating to form sodium nitrite and oxygen gas. Determine the balanced equation when 8.5 grams of sodium nitrate produces 6.9 grams of sodium nitrite. These are the 4 steps that you should follow. Pause the video, follow these steps, and then play to check your answers. No cheating! First, let's construct that equation. Sodium nitrate is our reactant, so that goes on the left of our arrow. Sodium nitrite and oxygen are our product, so that goes on the right hand side of our arrow. The law of conservation of mass tells us that the mass of the reactant must be equal to the mass of the product. So 8.5 grams take away 6.9 grams should give us the mass of our oxygen, which is 1.6 grams. Now let's work out the moles of our sodium nitrate. We first need our molar mass. 1 sodium, 1 nitrogen and 3 oxygen gives us 85 grams per mole. Moles equals mass over molar mass, so the mass of 8.5 grams over 85 grams per mole gives us 0.1 moles of our sodium nitrate. Then we work out the moles of our sodium nitrite. The molar mass is 69 grams per mole because we have 1 less oxygen in the compound. Moles equals mass over molar mass, so 6.9 grams over 69 grams per mole gives us 0.1 moles. And then finally, for oxygen, we have a molar mass of 32 grams per mole. Our mass is 1.6 grams, so 1.6 grams over 36 grams per mole gives us 0.05 moles of oxygens. Don't panic when you get decimals at this stage, and please do not round your numbers at this stage. Now we're on the second to last stage where we divide by the smallest number. This is 0.05 moles, so dividing each by 0.05 gives us 2 moles of our sodium nitrate, 2 moles of our sodium nitrite, and 1 mole of our oxygen. Therefore, this is the complete balanced equation. I hope you found all of that useful. Read the timestamps below if there's a certain section you didn't quite get, and I'll catch you guys in a bit.